This is your video guidance for completing the iXLs for L1, L2, L3, L14, and L15 in Algebra 2. These are all in this polynomial section here, and you'll see they're not started at the moment because I am making this video a little bit in advance. So the first one, L1, is polynomial vocabulary. And this section is all about telling how many terms a polynomial has, degree and leading coefficient. So you do want to make sure you go back and rewatch the notes video for this section to make sure that you know what all of those vocabulary words mean. Remember, before you start any of these sections, you can always click Learn with an Example. And so notice here it does say key idea, terms. That's the expressions or numbers that are added or subtracted. So that gives you some guidance on that. Now this one actually says degree instead of terms. Degree is the highest exponent in a polynomial. Well, this one has a 2t to the 2t plus 4. T is the only variable and its exponent is 1, so this is a degree 1 polynomial. This is also a degree 1 because the j has an exponent of 1. Number of terms. So terms are separated by addition or subtraction. This only has one term. Even though there is a negative out in front, there's not another number in front of that negative. So this also only has one term. This one, degree of the polynomial. So I have two different p's here. The higher exponent, though, is the 10. So 10 would be the degree. Let's see if we can skip and get some other questions. This one is asking for the number of terms and the degree. So I have my first term and my second term here. There's two terms, and then the degree is the highest exponent, which is 4. That again is asking degree and number of terms. Okay, this one, classify the polynomial. So we have trinomial, binomial, monomial, and one of these. Trinomial means trinomial means 3 terms. This problem has 2 terms, so this is not a trinomial. Binomial means 2 terms, so that would actually be our solution for this one. Monomial means 1 term. So 1, 2, 3, and then if it's 4 or something bigger, that would be a none. Classify the polynomial. This is where you go by the highest degree. So my highest degree here is 3. Degree of 3 is a cubic. If you had a degree 2, that is a quadratic. Degree 1 is a linear, and if you have something else, that would be a none. So this degree 3 is a cubic. And that's how you go through and do this first section here on L1. L2 is adding and subtracting polynomials. This is just going to be combining like terms. You do want to make sure you're careful with your positives and negatives here. So notice this is a subtraction. So if I pull up my pen here, I'm going to have 9w plus 5, and that's going to be minus 8w minus 5. When you're subtracting, you have to distribute that negative to everything in the second set of parentheses. So the 9w minus 8w is going to be 1w, or just w. And then the 5 minus 5 is 0, so I don't need to put plus 0, but you could for that problem. This one is an addition. So we could go through, you can rewrite it if you want to, but you're not changing any signs because you are adding. You are adding things that have the same power. So the 5n squared and the 8n squared, that's going to make a 13n squared. And then the 5 and the 19 add to make a 14. So you're just combining like terms. Let's go back and take a look now at L3. This is multiplying polynomials. These are going to start off with shorter questions and then move to some longer ones. So this one is a monomial times a monomial. The big numbers you're going to multiply together. So you're going to multiply the negative 4 and the 8, and that gives you negative 32. For variables, whenever we multiply those together, we add exponents. So 4 and 2 makes a 6. So that's going to be z to the 6th power. So negative 32, z to the 6th power. This one you're distributing. So you're going to take this and you're multiplying. You're going to distribute that through. And when you do that, negative r squared times negative 2r squared is going to be a positive 2r. And again, I have to add my exponents. So that's going to be to the 4th power. Negative r squared times a positive 4 is going to be negative 4r squared. And as you continue to move through this section, notice this is another monomial times monomial. If we continue through this one, remember anytime you have something squared, that's the same thing as having the same set of parentheses twice. So you would actually go through and do FOIL on this one. So 3n plus 1 times 3n plus 1. And I would multiply those and those and those and those. So when you multiply 3n times 3n is going to be 9n squared. 3n times 1 is 3n, and 1 times 3n is another 3n, so that's actually going to make 6n. So I have 9n squared plus 6n, and then my 1 times 1 will give me a plus 1 at the end. This is another FOIL problem, so you just make sure you do your first, outer, inner, last the way that you're supposed to. All right, the next one, L14. This is matching polynomials and graphs, and you can use some shortcuts with these as far as looking at what the degree is, looking at the end behavior in order to match them up. So with this one, I have a positive quadratic and a negative quadratic. Well, remember, positive quadratics open up and negative quadratics open down. Well, my graph on the right opens down, so that has to be my negative. And my graph on the right opens up, so that has to be my positive. You could also type these equations into Desmos to match up to see which one is which. This one gives you some cubics, so you can think about which one is positive and which one is negative. For cubics, they act very much like linear. So you see this one on the left-hand side, the left arrow starts down and the right arrow starts up, so it has a general positive movement. That would be a positive cubic function. The one on the right, the left arrow starts up and the right arrow starts down, so it has a general negative movement. That would be the negative. And when I refer to polynomials as positive or negative, that does refer to the leading coefficient. So that's the term, the number in front of the exponent to the variable to the highest degree. So there's a positive at the beginning of this g of x. There's a negative at the beginning of this f of x. You can also use y-intercepts. The y-intercept is the number at the end of your polynomial, and that's where you have to cross the y-axis. So you notice at this one, there's a 2 at the end. This one has a negative 4 at the end. Well, if I look at this equation over here on the left, it looks like it's crossing at a positive 2. And on the right, it's crossing down at negative 4. So that's where those are going to line up. And that's going to be how you complete these problems. The last one we need to go through is L15. L15 is going to be domain and range of polynomials. And this is using interval notation. Remember, domain is your left to right. Range is going to be your up and down. The domain for all polynomials should be all real numbers, which is negative infinity to infinity. You're going to get two different choices here because there are sometimes when the range is also going to be that. But your domain for all polynomials is going to be negative infinity to infinity. So it's real easy to just drag that down. Now, the range is bottom to top. The lowest number that we go down to on the y is negative 5. And then we're going up forever. So we need to do negative 5 to infinity, which is going to be this first option here for the range. So again, remember, domain is left to right, range is bottom to top. Anytime you have a cubic function, like this one, how one end starts either up or down, the other end starts opposite, where both ends are not going the same direction, those are always going to be all real numbers, which is the negative infinity to infinity for both of them. This one is another quadratic, so again, got to put that in for my domain. This one reaches a high point of positive 7, and then it goes lower Well, the only one that has the positive 7 in it is this, and it goes from negative infinity up to positive 7. Anytime you list these in interval, you always list lowest number to highest number. So since 7 is the highest number, it has to go second. Okay, and that should be good enough. Notice this one does have two kind of low points, but you want to take the absolute lowest, which is going to be this -6. That's going to be for your bottom to top. So that's actually going to be our range. Domain is always all reals for something like this. I hope this was useful. Please go back through and watch anything that you were not sure of, and this should help you be successful in completing these iXLs.